Download this code from codegive.com, link in the description below. Diagnosing database connection pool issues can be a complex task, as it often involves understanding both your application's behavior and the configuration of the database and connection pool. This tutorial will cover common signs of connection pool issues, tools and techniques to diagnose them, and a code example demonstrating basic connection pool usage and troubleshooting. What is a connection pool? A connection pool is a cache of database connections that can be reused, which improves performance by reducing the overhead of establishing a new connection for every request. However, if the pool is not configured correctly or if there are issues in the application, it can lead to various problems. Common signs of connection pool issues. 1. Connection timeout. Applications hang or throw exceptions due to the inability to acquire a connection from the pool. 2. Too many connections, hitting the maximum connections limit on the database server. 3. Slow performance. Queries take longer than usual, possibly due to contention for available connections. 4. Resource leaks. Connections are not returned to the pool properly. Diagnosing connection pool issues. 1. Monitor connection pool metrics. Check metrics such as active connections, idle connections, and maximum pool size. Use tools provided by your database or connection pool library, example Hikari CP, C3P0. 2. Enable logging. Most connection pool libraries allow you to enable detailed logging to see when connections are acquired and released. 3. Database logs. Check the database server logs for connection errors or warnings. 4. Profile your application. Use profiling tools to analyze your application's performance and resource usage. 5. Review connection pool configuration. Ensure the pool size, timeout settings, and other configurations are appropriate for your application workload. Code example. Below is an example using Hikari CP, a popular connection pool library for Java applications. This example includes basic connection handling and some logging to help diagnose issues. Maven dependency. XML. Dependency. Group ID comsaxer/group ID. Artifact ID Hikari CP/artifact ID. Version 5.0.1/version. /dependency. Database configuration and connection handling. Java. Import comsaxer.hikari.hikari config. Import comsaxer.hikari.hikari data source. Import java.sql.connection. Import java.sql.result set. Import java.sql.sql exception. Import java.sql.statement. Public class database connection pool example. Private static Hikari data source. Public static void main, string args. Setup data source. 4. Int I equals 0, I10, I++. New thread, database connection pool example execute query, .start. / shut down the data source when done. Runtime.get runtime, .add shutdown hook, new thread, database connection pool example shutdown data source. Private static void setup data source. Hikari config equals new Hikari config. Config.set JDBC URL, JDBC MySQL /localhost 3306/mydatabase. Config.set username. Config.set password. Config.set maximum pool size, 10. Config.set connection timeout, 30,000, /30 seconds. Config.set idle timeout, 600,000, /10 minutes. Config.set max lifetime, 180,000,000, /30 minutes. / enable logging. Config.set pool name, my pool. Config.set connection test query, select 1. Data source equals new Hikari data source, config. Private static void execute query. Try, connection equals data source dot get connection. Statement equals connection dot create a statement. Result set equals statement dot execute query, select asterisk from my underscore table. While, result set dot next. System dot out dot println, data, plus result set dot get string, my underscore column. Catch, SQL exception e.print stack trace. Private static void shutdown data source. If data source equals null. Data source dot close. Explanation. 1. Hikari CP configuration. The Hikari config object sets up the database connection parameters. Key properties include maximum pool size, connection timeout, idle timeout, and max lifetime. 2. Connection handling. Connections are acquired and released using a try with resources statement, ensuring they are returned to the pool. 3. Thread creation. Multiple threads are created to simulate concurrent database access, which can help reveal connection pool issues. 4. Logging. You can enable logging of connection events in Hikari CP to help diagnose issues. Conclusion. Diagnosing database connection pool issues involves monitoring, logging, and analyzing both your application and database behavior. Using a connection pool like Hikari CP with proper configuration and error handling will help mitigate many common issues. If problems persist, deeper analysis of your application logic and database performance may be necessary. Diagnosing database connection pool issues is a critical task for developers and system administrators, especially in applications that rely heavily on database interactions. Connection pool issues can lead to performance bottlenecks, application crashes, or unresponsive services. This tutorial will guide you through diagnosing these issues, along with code examples to help illustrate the concepts. What is a connection pool? A connection pool is a cache of database connections maintained so that connections can be reused when needed, rather than being created and destroyed on demand. This improves performance and resource management. Common symptoms of connection pool issues. 1. Slow response times, increased latency when executing database operations. 2. Connection timeout errors, errors indicating that the application cannot obtain a connection from the pool. 3. Excessive resource usage, high CPU or memory usage on the database server. 4. Application crashes, out-of-memory errors due to too many connections being opened. Steps to diagnose connection pool issues. 1. Monitor connection pool metrics. Most connection pool libraries provide metrics and statistics. Look for active connections, the number of active connections in use. Idle connections, the number of connections that are currently not in use. Max connections, the maximum number of connections allowed in the pool. Wait time, time spent waiting for a connection to become available. You can use tools like JMX, Java Management Extensions, for Java applications or built-in monitoring solutions for frameworks like Spring or Hibernate. Example, Java with Hikari CP. Java. Import comsaxer.hikari.hikari config. Import comsaxer.hikari.hikari data source. Public class database connection pool. Private static Hikari data source. Static. Hikari config equals new Hikari config. Config.set JDBC URL, JDBC MySQL /localhost 3306/MYDB. Config.set username, User. Config.set password, password. Config.set maximum pool size, 10. Config.set connection timeout, 30,000//30 seconds. Data source equals new Hikari data source, config. Public static void print pool metrics. System.out.println, active connections, plus data source.get Hikari pool mxbean, .get active connections. System.out.println, idle connections, plus data source.get Hikari pool mxbean, .get idle connections. System.out.println, total connections, plus data source.get Hikari pool mxbean, .get total connections. System.out.println, max connections, plus data source.get Hikari pool mxbean, .get max connections. System.out.println, connection wait time, plus data source.get Hikari pool mxbean, .get connection timeout. To analyze connection leak. A connection leak occurs when connections are not properly returned to the pool. This can exhaust the pool and cause timeouts. Best practice: always use try with resources or ensure that connections are closed in a finally block. Example of a connection leak. Java. Public void fetched data. Connection equals null. Try. Connection equals data source.get connection. / execute queries. Catch, SQL exception E. / handle exception. / connection is not closed here, leading to a leak. Correct way to handle connections. Java. Public void fetched data. Try, connection equals data source.get connection. / execute queries. Catch, SQL exception E. / handle exception. 3. Review application logic. Ensure that your application logic is not repeatedly opening and closing connections unnecessarily. Use connection pooling effectively by reusing connections for multiple transactions. 4. Check database server resources. Sometimes the issue may lie with the database server itself. Monitor CPU, memory, and disk I/O metrics on the database server. Ensure that it has sufficient resources to handle the connections. 5. Adjust connection pool configuration. If you are consistently running into issues, consider adjusting the connection pool settings. Increase max connections, if the application requires more concurrent connections. Adjust connection timeout, if connections are timing out too quickly. Idle timeout, set an idle timeout to close unused connections. Example configuration adjustment, Hikari CP. Java. Config.set maximum pool size, 20, / increase max connections. Config.set connection timeout, 60,000, / increase timeout to 60 seconds. Config.set idle timeout, 300,000, / set idle timeout to 5 minutes. Conclusion. Diagnosing database connection pool issues requires careful monitoring, analysis of application logic, and adjustments to configuration settings. By following the steps outlined in this tutorial and utilizing the provided code examples, you should be better equipped to identify and resolve connection pool issues in your applications. Regularly reviewing connection pool metrics and ensuring proper handling of connections can prevent many common pitfalls associated with database interactions.